So once again, everybody, thanks for coming, right? I hope you can hear me. Hope the audio is clear. Do let me know if I need to speak a bit louder, all right? Thanks everyone for being here. I know it's your holiday. I hope you all are having a nice break. So I organized this session a little bit last minute, so I didn't really expect to see many people here. But regardless, I will record this session and post it up online after this session, right? So you all can just sit back and relax. If you like to take some notes, of course, that'll be great. If you like to follow along, we'll go through some of the software that we'll be covering today, right? We'll be covering a little bit of MagicaVoxel, a little bit of Blender, and then we'll be seeing all these things kind of move into Unreal Engine 5. Okay, so we're just going to pick one of the commercial game engines to use. One of the reasons why I'll be picking Unreal Engine 5 is also because there are some tools in there that may prove to be quite useful for those of you who are new to 3D modeling. Okay. Right. So let's get started. Okay. So today's sharing session is Introduction to 3D Assets. It is designed in mind to help some of you get started on creating 3D assets for your GAM project, the 3D GAM project coming in fall, right? So I thought maybe this might be a good time to get started. That way you'll have a little lead time to practice right before the semester begins. Also, I know that some of you, there's two more reasons for this, right? Some of you may be taking the CG125 module in fall, and that module will train you primarily in 3ds Max, right? So it's a very mature software. It's very widely used in the industry, so it's very good software to learn. A lot of very useful tools there, and it will be structured mainly to teach your modeling, UV unwrapping, texturing, as well as rendering, right? So you get a nice picture of your model for your portfolio. As I understand it, it doesn't really cover much in the way of animation. So I hope to kind of cover some of that here. And also I'll be opening up more options to all of you during this session. So I won't be covering 3ds Max. I'll be covering some free software, right, which I will recommend to you all, which are very mature in their own right. Okay, and very good to use. Okay. So one reason why I'm going for free software in this case is because some of you may not have access, right? So to the licensed software at home. Some of you may prefer to work at home and practice at home. So these free software will be very easy for you all to get. And sometimes when things go into lockdown, right, we never know if that's going to happen again. This free software would really make things a lot easier for all of you. Another reason is because some of you may not take CG125 at all, and you may even end up in a team with no one, right, who have experience in 3D modeling. So sometimes the rest of the team has to kind of chip in. Okay. So I hope that this session will be useful to you all in general. But if nothing else, right, I hope that this little sharing session will be a good introduction to 3D modeling for all of you, because it's just a fun activity to and skill to pick up, right? For you to create stuff, right? And also it will no doubt help you in other areas as well if you're into prototyping 3D games, or programming and getting into rendering and stuff like that. So this session will give you all some basic skills to cover some of the creation process. Okay, right. So about this talk, right? So once again, I will be recording this session, and it will be uploaded to my new YouTube channel. I say new because I actually have a few YouTube channels that I've created over the last few years, ever since I entered into education. And I have, to date, I think about 400 plus videos uploaded. Not all of them are tutorials. A lot of them are kind of consultation videos that I run with students, where I share how to fix problems and things like that. So I'm actually in the process of consolidating all those videos, and maybe I'll be redoing some of them and I'll be posting it to a new site. Let's see if I can just quickly share with you, right, that site. So the link will be provided on Game Central, so you don't have to worry. But if you're looking to take a look, it'll be this channel over here. If you try searching for Jonathan Quek or try searching for, you know, Tupo Chicks, you probably won't find me. If you try searching for one of the videos that I uploaded recently, Meta Reel, you'll be able to find a channel. But no worries, right? I'll get the link provided in Game Central. Okay. Also, there will be some working files that I'll upload, and I'll provide the links in the video channel as well in the description, so you can pick it up from there. So as I mentioned before, right, today's session is targeted at those of you who are completely new to 3D. Okay, so we'll assume a lot of things and we'll cover a lot of things from the ground up. I'll try to keep everything within the hour. I'm very bad at this, but I'll try my very best. Okay, I have failed the last few runs that I've run this session, but I will get better. Okay, I don't want to take up too much of your time. Maybe some of you have already spent a whole day of watching industry talks already. So let's try to keep it short. Yeah. I also try to minimize the use of slides because slides are usually what keeps me rambling off tangent. So we'll just stick to live demos as much as possible. Okay. Right. So so please feel free to drop in questions in the chat window, right, as you go along. Don't feel shy about it. I will look at the questions from time to time, and then I'll address them appropriately at the right moment, right? So if you see in the moment you kind of run into something that I mentioned or I showed, and you'd like to find out a little bit more about it, please feel free to just drop a question in. Okay. All right. Cool. Let's start it. Let's have. Okay. So as I mentioned before, some of the things that we'll be talking about today we'll cover some basic concepts of working with 3D assets, and then we'll go into some live demos, and we'll try to cover some modeling, UV unwrapping, texturing, and animation. Okay, I hope. And these are some of the software that we'll try to cover. Again, these are all free software that you can get very easily. Of course, there are a lot of excellent industry-grade licensed software that's available to you all in the school labs. But we won't cover that in today's session. Okay. Right. So let's begin, shall we? Okay. 3D modeling assets for game engines, right, or for your game applications. One of the first things that I usually recommend to all of you is to first get familiar with the workflow, because there are two components to this, right? There is the what buttons do you have to press in order to make what you have in your head, right? And then there's the creative part, right? I have this image in my mind that I like to create into 3D. You know, what is the shape of it, what's the color of it, and so on and so forth, right? So there's these two parts to it. There's the creative side, and then there's the technical side. So if I were to kind of draw a parallel to drawing, right? So if you're drawing, you're basically doing the same thing. You're thinking of an image in your head, and then you're kind of asking your hand to translate that into the paper. So because you have been using your hands, right, and the pen, right, for many years already, this process is not really that difficult, right? So you don't think so much, you just kind of move down and then, you know, try to create that image, right? So the technical part of creating this image from your mind is a little bit less. You spend less effort on it, okay? So you spend more of your brain power on creating that image, right, forming the image in your head and creating it. So it is the same sort of, right, with 3D software. In other words, the more familiar you get with the software, right, the easier this process is going to get for you. Okay? So what I usually recommend to most people is try to pick up a simple kind of exercise in the 3D software that you're picking up, right, and then go through that whole process over and over again without you know, worrying too much about, you know, the creative part, right? It is only when the first part gets better, then the second part is going to flow better as well. Okay, so here we go. I'm just going to use 3ds Max first to demonstrate the flow, right? Then after that, I'll move into the other software. Okay, so your process begins with a software like this, and you use the software to create a 3D shape. Okay, and this 3D shape has to be created in the right dimension. So in other words, you have to create it at a dimension that you understand. So for example, in this cube, okay, I would like to create a 1 meter by 1 meter by 1 meter cube, right? So I understand that I am plugging these dimensions here. You can see that it's written here in cm. Okay, then after that, the next part of the process is to attach a texture to it, right? I'm skipping a lot of steps here, right? Making it look very easy, but we'll go into the detailed steps later, right? So I'm gonna drag in a texture, right? So this is what we call a bitmap texture, right? We you know, JPEG, PNG, and so on and so forth, right? Okay. In a very easy step, I'm just going to drag this onto the model, and you will see the texture is being rendered on the surface of the 3D mesh, right? The same texture is being rendered on all 6 sides of this cube, right? Then the next part of this process is then to export the model. So I'm going to export this model, and they're going to ask for a format. And the format of my 3D model, I'm going to pick FBX, right? So the FBX is kind of like a container format that supports a lot of many types of data. So what kind of data does it support? It supports things like mesh data, UV channels, textures, right? It will even pack, you know, bitmap textures into the FBX, right? So it may not be 2 separate things, right? It will even pack animations, right? Bone data into it, right? So basically everything that we need to make a 3D game asset, right? So that's why the FBX format is a very popular industry-grade format to use. Okay, we'll talk a little bit more about formats in a bit, right? So I'm going to export this, right? Okay, and they're gonna ask for some settings over here, right? Generally, the default settings will work just fine. Okay, and then done. So this concludes your workflow in the DCC, right? The 3D digital content creation tool side of things. Okay, so and then it basically gives you, okay, from this process, it gives you an FBX file that you can now bring to your game engine. Okay? Right. So we're going to now fire up the Unreal Editor over here. Okay, and then we're just going to drag in the FBX file into the editor, and then they're going to ask for some import settings. Again, the default ones will do. Okay, right, and we're done. Okay, so at this stage, we can now drag in our object into the scene, right? And you can see that when measured against this grid here in Unreal, right, this grid is actually a 1 meter by 1 meter grid, right? You can see that my 1 meter by 1 meter by 1 meter cube came from 3ds Max to Unreal Engine exactly as I ordered, right? I wanted a 1 meter cube, and it came in as such, right? So this might seem fairly obvious to all of you, right? But there are some kind of pitfalls to watch out for, right? Because this is a very simple kind of example. Okay, right. So what you're going to see in the import, right, is that you're going to see a mesh asset, what they call a static mesh, right? So there are 2 types of assets that you will essentially be working with. One is a static mesh, something like what we've just created, right? So what a static mesh is basically kind of like a shell, right? It just sits there and looks pretty, right? It looks and it just sits there, it doesn't do anything, right? So this is what we call static mesh. As opposed to this, right, if the second asset that we'll deal with is an asset that basically moves, okay? So it carries animation and it will deform, right? It will change its, you know, parts of its mesh, right? For example, it's going to move its arm up and down, right? And so on and so forth. So for this kind of asset, we'll call them skeletal mesh, right? Because these are meshes that also come with bones and animation data, okay? So these are 2 types of assets. When you're working with environment assets, basically anything that just doesn't move, right, you're working with static mesh. Or anything that you would like to move using script, right, those can be static mesh as well. But anything that you would like to animate inside the DCC software, right, using bones, okay, then those will be skeletal mesh. So very commonly, the character models, or, you know, things like vehicles and turrets and treasure chests, all of these will be skeletal mesh. They will use, very often they will use bone animation in them. Okay, So just try to keep your mind, keep this in your mind, right? The other thing that you're gonna notice is we brought in the texture, right? So that's looking as we brought it in as, okay. And then we have something that we didn't create, right? As you noticed just now, we had the cube, we dropped in a texture, we brought it over, right? Okay, and this is called a material. Now the material, okay, is something that Unreal Engine kind of created for you when they imported in the texture. Now it's very important for you to know this, right? Because very often, whatever materials that you use in your DCC software do not carry across to your game engine. Your game engine usually creates its own materials. So whether it's your custom engine or Unity or Unreal, right, they're going to use their own materials. So the only thing that's really going to come across from your DCC software is your mesh, your textures, right, and your animation data, right? So anything that you do with the materials on that side of things, it's not going to come over. You have to recreate it inside your game engine. Okay? And what is a material, right? What you guys what you all have to sort of understand about materials is that it's kind of like a cooking recipe, right? Where at the end of the cooking process, you're gonna get a dish. So imagine that you all want to cook a steak, right? So what you input into that cooking recipe is probably a slab of beef, right? So that slab of beef is your texture, right? Of course, there are other ingredients as well, like pepper and potato and carrots and whatever, right? And those also come in as texture samples and input data, right? And once you have those ingredients into your pot, there is a certain process that you kind of run through to turn those ingredients into a finished product, right? And those are kind of what we call instructions, right? So what a material is a set of instructions, right, combined with these ingredients, and after cooking everything, it finishes up in this form, right, as a finished product. And that, my friends, that material will appear on the surface of your mesh. Okay, so it's a little bit convoluted way of explaining materials, right? But it's an analogy that I kind of like to use to help you understand what's going on. In the most basic form right now, we are taking just the beef, right, this texture sample here, and then we're just connecting it to the base color node here, right? So we're just telling the material, just show us this, right? Also included in our instructions, right, is that we are telling this material to use the lighting that's present in the scene, right? So if you see this shading model here, default lit, right? So you are basically telling the software to use the lighting data and blend it with the texture data, right? The color data that comes with texture to show us the final result over here. If we do not have those instructions, for example, if we change this shading model to unlit, okay, like so, and we save it, right? Just give it a second. We got to plug this now into emissive color. Okay. Right. So what you're going to see now is the texture, right? The color data that comes from the texture without the lighting data from the scene. So if you all remember on the side of this cube previously, it was a little bit darker, right? Because that side of the face was in shadow. That was the lighting data multiplied on top of your texture data. So without those instructions, it will just render the texture color on top, okay, of everything. Okay, so I hope you all kind of caught that, okay? This is just kind of a short intro to the overall kind of workflow. Now, so these are the three basic things that we'll work with very often in 3D modeling and working with 3D assets. So what I often recommend to people kind of getting started is to get familiar with this workflow, right? So quick recap, right? We start in a 3D software, we create a mesh, right? We manipulate it any way we want, we drop in a texture, then after that we shift it, we export it to FBX format, and then we import it into a game engine and we check it out, right? See if it looks exactly as we had intended it to be, okay? Now, so that's in a nutshell. Now, let's cover some quick concepts. Okay. So when working with 3D models, something very important to understand is what are 3D meshes essentially made of, right? So what you're going to see very often in 3D meshes is we'll be working a lot with vertices, right? So we'll place one vertex, and a vertex is essentially a point, and every point has it has an ID number, right? Vertex 1, vertex 2, vertex 3, vertex 4, and it will also have a coordinate in 3D space. So you can see these 4 vertices that we have here on the screen. Okay, they are laid out on a 2D plane, so their coordinates are as such, right? So 0, 0, 0, 1, 0, 0, and a little bit lower, 0, minus 8, 0, 0.8, and so on and so forth. Okay? So these 4 vertices are part of a 3D mesh. And the next step, right, of this process is that the system will kind of draw a line to connect these dots, right? And it prefers to kind of connect them in squares and what we call quads. Okay, but basically these lines are called edges, right? So we have the points, which are vertices, and then we have these lines, which are edges. And then after that, when these lines kind of close up a shape, we have a face, right? So if you select this area enclosed by the lines, by the edges, we have a face, okay? And these faces, when there are 4 sides, they are often called quads or polys, right? Do forgive the jargon. Sometimes the jargon gets a little bit confusing, right? Polygons and polys and triangles and so on and so forth. Sometimes they're even used kind of interchangeably. But anyway, if you see something 4-sided, these are quads and polys, right? And in general, you want to work with quads and polys when you are developing your model, right? Because it is easier to make changes when they are in these square format, right? Because once you kind of draw a line across, okay, and connect these vertices, right, to create triangles, right, then the surface of this face is basically locked down already. Ultimately, right, when the mesh goes into a 3D game engine, right, it will be turned into triangles, right, whether you like it or not. Whether you work in quads, once it goes inside a game engine, it will turn into triangles, right? And there's a reason for this, right? It's because of the way that a square kind of bends, right, when you move one of the points out of the way. So if I move this point here, right, if I have a square, if I move this point here down, okay, right, this shape bends this way, right? But how does the software know if I meant for the line to kind of cut across between these 2 points or to cut between these 2 points? Okay, so at some point, the rendering engine needs to make a decision, so they make a call for you, right? Okay. Now, the next thing to understand about these quads and these faces and these triangles is that there is only one true side to it. Okay. Now, and this side is usually called the face, and then the reverse side of it is called the back face. Okay. So by default, right, every face is single-sided, right? So there's only one true side, even though some of you may be a little bit confused by this, right? Because when you open up your 3D software, very often you see both sides getting rendered when you create a plane. But in reality, they're just rendering it to make things convenient for you. But there's only really one true side. And that one true side is the side that receives lighting. Okay? So if light is being cast towards the back face of a polygon, it will actually turn black. Right. So how do we know which side a face is facing? Okay. One way is to turn off that convenient feature that the 3D software is using, right? So if you find a way to do a back face cull, right, then you'll be able to see the faces for its true side, right? So you're gonna see, normally you're gonna see this on the left, right? And then when you turn on back face cull, you're gonna see this on the right. So this is what I mean by when a 3D model is a shell, right? So when you delete some of the faces and you look inside, really there's nothing, okay? And you can see right through to the other side. You won't even see the face of the side that's on the opposite end, right? So all these faces actually have a normal line, right? So this is what we call a face normal. And this is a line that sits somewhere in the middle of this area here and then kind of points perpendicularly outwards, right, by default, right? So the true face is being indicated by this face normal, and that's not the only normals that we have, right? We have the face normals and we have the vertex normals. So remember the vertices that we're talking about just now, right? So those vertices will actually have a normal line of their own. Okay, so if you have, wow, that was fast. I'm really not good at keeping time. Anyway, right, these vertex normals are important, right? They'll tell you which way the mesh is facing. Okay, let's breeze through quickly. Right, so this is very important because with working with some models, you have this thing called smoothing groups, right? So when you see facets on your mesh, it is because the vertex normals on the mesh are split, right? And they are kind of pointing in different directions. That's why when lighting data hits it, it looks like this. If you apply smoothing groups, right, and then you merge the vertex normals, you can see the lines are merged now, right? It will render as though it is a perfectly smooth surface, okay? Now, so that's a very important concept to understand with 3D models. So now let's get into the making of. Okay? So we'll start simple, right? And one of the simplest ways to get started with 3D modeling is to use a software called MagicaVoxel. So MagicaVoxel works with voxel style modeling. What it is really, it's a little bit like pixel art, right? They don't have vertices, right? They don't have 4 points to define a face. They just have a single point, right? And in that single point, they will generate a cube, right? So once you place a point next to that point, right, they will create a cube that that fits perfectly next to it. Okay. Now, this software is free. You can download it from the MagicaVoxel website. I'll post the link later. And when you run it, okay, this is basically what you will see, right? And let's go through some of the controls over here. Okay. Basically, when you have a workspace like this, right, you can clear it by pressing the tool clear button, right, to remove any voxels that are already inside. Okay. And this area up here, you will see it is the canvas size. So the outlines of this cube that you see here is actually your working space, right? So nothing will exist outside of this working space. And this working space is exactly 40 voxels by 40 voxels by 40 voxels. So just to get started, maybe we can work with something smaller, right? We can maybe work with 15 spacebar, 15 spacebar, 15, okay? And we can go with something smaller. You can use your mouse wheel and middle mouse button, okay, to pan and to zoom. And if you hold on to the right mouse button, okay, you can rotate, right? So these are your basic controls. Right, so the concept again here is just to add points, right? So you can come over to the left-hand side over here, and you click attach, right? And that will basically add voxels into this space, right? And you have the choice of either using voxel mode, which is kind of like a dotting mode, right? Or you can use the face extrude or element selection mode, right? But we'll work with the voxel mode, right? So in voxel mode, again, there's 2 options for you down here, right? You have the 2D mode and the 3D mode. So we'll go through what they basically do. If you use the 2D mode and you click into the scene, you basically add a voxel, right? If you mouse over one of the sides of this cube, right, and then you click again, you basically add a voxel in that direction, okay? So you can easily add and create shapes to this 3D scene over here using this style, okay? Right, very easy stuff, okay? Now, the 3D option over here, okay, allows you to do basically the same thing, except if you increase the voxel size here, okay, you will get something that looks a little bit like a cube, right, kind of pop up. Right, so if I increase this to voxel 3, right, you can see that my brush, right, changes to something that looks like a sphere. So this will kind of allow you to add a lot more voxels very quickly, right, into the scene, which is kind of cool, right, because with this, you kind of very rapidly generate what looks like a voxel landscape, right, just by kind of moving this brush around and clicking onto the scene, okay. So this kind of looks a little bit like canyon with a little valley here, kind of stuff, right? So very cool. Okay. Then the next thing that you want to do is to play with, right? Is to perhaps to paint this object, right? So you can go over to the paint tool over here, okay, and then you can pick one of the colors over here. Now this palette here is quite important, right? Because this whole palette here will essentially become your texture bitmap later on. Because this is voxel style. Basically, every every one of these cubes will get rendered in one color, right? So let's maybe pick like green color, like so, right? So you can see that I'm not adding any more voxels, right? I'm just coloring the voxels that are in the scene over here, okay? Right, so again, it's very easy. I'm just gonna click dragging and painting all these voxels over here, okay, like so. Okay. If you pick another color, right, you can do the same, right, to some of these things over here. Okay, so very easy stuff. Okay, kind of dot around so you get a little bit of that pixel art dithering effect, right? Okay, so we have a simple kind of 3D model generated here already. If you want to remove some stuff, you can go to erase. So once again, very easy to handle. Okay, you can delete all these things away. Okay, and you uncover the voxels hidden underneath. So this is very Minecrafty way of modeling, right? And very easy. Okay, we have a few GAN projects that are done in this style, right, by people who picked up 3D modeling for the first time. So they found that this is a great way to kind of get into creating assets. And because it's so easy, actually a large number of the team, right, we actually had, 3-4 members of the team who, kind of chipped in their time, an hour a week, right, just to create simple assets, right, a chair, a flower, a rock, just small stuff, right. And because it's voxel style, everybody's art standard basically flatlined, right, and they all look the same. Okay, so there was no kind of incoherent quality that was coming out. So this is a very good option for you all to consider. Okay, if you have no art talent in your team at all, okay, or you have art talent in the team, but he's way overworked, so you want the team members to chip in. Okay, this is a great workflow to adopt. Now, so this is basically how to use MagicaVoxel in a nutshell, right? And when you're done, you can simply come to the bottom right hand corner over here, okay, and click on the export button, and you can export this model as an OBJ file. So remember, these are all in voxel format, right? So once you export it, they will sort of convert the data here into polygons and vertices and so on and so forth, right? So let's see what happens, okay? So I'm going to create a object. I'm going to put it here. Okay, we're going to call this our test terrain. Okay, so we're going to use an OBJ format. Now, we used an FBX format just now, right? And we're using an OBJ format this time. A lot of y'all will really like to use OBJ format. It's also a very common format to use. And it works perfectly for things like static meshes, right? So mesh data and texture data, UV channels, OBJ is perfectly fine to use, right? The only thing that OBJ doesn't support, right, in our workflow is it doesn't support bones, it doesn't support animation. So this is something for you all to consider, right? Okay. So if you're just working with creating some, basic static assets, OBJ will work just fine. Okay. So now we have the OBJ exported, right? Let's bring it into Unreal. Okay, so the files generated are this OBJ file, an MTL file, as well as this PNG file here. Okay, let's take a look at the PNG file really quickly. Okay, let's see. And what we have is a very strange texture, right? It's a texture that is basically made up of different pixels. Okay, it's a single pixel long texture. I believe this should be about 256 long by 1 pixel, and then every pixel is a different color. Right, and this is because all your meshes, right, are sampling one of these pixels in this texture. Okay, so let's drag this in. Right, and I think the default settings should work just fine. Let's import, and let's take a look. Right, so once again, the texture was automatically imported for us, and a material was created for us. Let's take a look at the mesh. Now the mesh is very small. Okay, so this is something to watch out for as well. Perhaps during import, you like to import it at a larger size. Okay, and you also notice that the mesh is sort of rotated as well on its side. Okay, so you have to kind of flip it back around. Okay, so essentially, right, for a lot of you who are not very confident, right, of 3D modeling, right, do start with this process, right. I highly recommend it. You can use MagicaVoxel just to get started, right, creating some 3D models, and you know, getting used to that workflow, right, of bringing them into 3D engines and stuff like that. Okay, let's take a look at what's possible, right. They have some sample files here for you all to refer to. Okay, so for example, let's see, right, so these are some examples of what's possible using voxel art, and what you can do is that you can actually take some of these reference models and just modify it, right. You can extract it from, change it up from there. Okay, let's see, there's a castle model, that's pretty nice. Okay, they even have these cute little character models that you can use, right, to, you know, to modify, right. So you can use this as a base, and then, you know, you can create your own characters from here, right. I think this is a 2D, right, so this probably won't be very relevant to you guys. Okay, some Monument Valley type of objects. Okay, and even whole rooms, right, is possible as well. Okay, so I guess the only thing that you know, student teams have kind of struggled with when starting out with this workflow is getting the right pixel resolution, right. So as you can see, if you're trying to create a teapot, right, you can make something that looks like a teapot, and it looks very, you know, almost high detail. Okay, but if your character models look like this, then you definitely do not want a teapot that looks like this in the scene, right. The pixel resolution just doesn't match. So use your own kind of pixel art sensibilities when planning for this. Okay. All right. So as I mentioned before, okay, this software is voxel style and exports OBJ, so it will not support animations, right? So if you do intend to use this workflow, you will still need to pick up a little bit of Blender or 3ds Max or Maya after this, because you know, all the animations and the bones kind of stuff is handled in those software. If you're using this to generate environment assets, right, you can basically stop here and then go to the game engine. If you want to use this to generate characters, okay, and then use them for animations, there's a little bit of a preparation process where you have to basically just separate some of these body parts away from each other so that you can skin them properly in the 3D software. Okay, so I'll go into the detail into this in a separate video. I'll post a link to it. Right, you can check out my channel for it when I upload it. Okay. Right, so let's end the MagicaVoxel side of things for now, and then let's hop over to the next software. Right, so the next software we're going to cover today is Blender. Right, so Blender is a good kind of substitute for 3ds Max or Maya if you all if you want to get into polygonal modeling, right? Basically working with vertices and edges and faces and doing animation, okay? So if you are kind of working with certain kind of art style, let me just show you some examples. So if you're trying to make anything that looks like this, right, then you definitely want to use Blender, okay? Right. So when working with 3D software, it is quite important to get used to the concept or the style, right, associated with that particular software. Sometimes 3D software, they work with a certain kind of logic, right? And depending on the individual, right, some software are just better for you than others. So it's not really a matter of whether or not this software is better than the other. It's a matter of, sometimes it's a matter of resonance, right, with your style. I have spent years trying to pick up 3ds Max because that's just what the company used. But I remembered that when I first used this software called XSI, I picked it up in less than a month, right? That it had that kind of difference for me. Anyway, with 3D software, what you have to kind of get used to is this kind of orbital camera format, right? And you also have to get used to the plethora of menus and buttons that are available, which is very daunting, right, to everybody. It's very confusing, it's very daunting. So it's usually easier for you to learn if somebody kind of walk you through the basic tools, right? And then you'll just kind of familiarize yourself with those basic steps every time you start. So let's get started. Okay, we have the Blender mode, Blender window open here, and the different processes of creating a 3D asset, right, is split up into these different tabs up here. So you have a tab which is your default tab, which is a layout tab, right? And then there's a special tab especially for modeling, and then there's a special tab for UV editing, and then there's a tab for working with materials, and a tab for animation, right? So we'll be covering these 4 tabs in this walkthrough. Okay. Okay. And what happens when you go into these tabs is that certain options kind of get locked and unlocked, or hidden and unhidden, right? So it's very contextual. There are certain features that will only show up when you go to the animation tab, such as this timeline over here, okay? Or the UV editing tools, right? They'll only appear in this tab. Okay? So it won't appear in this tab, only in those tabs. Okay. The other concept that's very important to know in Blender is this concept of modes, right? So when you're kind of working with objects, right, like a camera object and a light object and a mesh object, right, you're working in the object mode, right? But if you want to dive in one level deeper to change something about that object that you selected, then you have to go into the edit mode. Okay, so that's very important, right? And then when you're done editing that object, you want to go touch another object, right? Then you have to exit that edit mode and go back to the object mode. Got it? Right? So object mode, dive deep into edit mode, then dive out again, right? And to do other stuff. Okay. So to toggle between these 2 modes, you use the tab button. Okay. So if you hit the tab button, if you look at the top left-hand corner over here, you have the edit mode. Okay. If you hit tab, you toggle between object mode and edit mode, right? So you have to select object first, right, in edit mode, in object mode. Then you hit tab to go into edit mode. Okay. Then in this mode, you'll be able to do things like select vertices, okay, or select edges. So you can use the 1, 2, 3 button, 1, 2, 3. Okay, you can see the options up here change. So this will toggle between vertex selection, edge selection, okay, and face selection. Okay, so 1, 2, and 3. Okay, so with 1, I can select vertices. With 2, I select edges. 3, I select faces. Okay, right. So to control the camera, you have your middle mouse button. Okay, but to move the camera around, you have to hold Shift. Okay, Shift middle button. Okay, you can see the controls over here, right? Zoom is also mouse. Okay, so that's easy. Okay, so in object mode, I'm able to change the position of the object. Okay, so you will go to, let's see, you can, what you want to do is you actually want to memorize some hotkeys, right? That would be the best way to do it. But if you're somebody who's used to using gizmos, then you can come to this option up here under gizmos. Okay, you can open this up and you can check these boxes here: move, rotate, and scale. Right? So you can check these options, okay, and then these gizmos will become available to you, and then you can move these things around. You can rotate them. Okay, you can scale them. Like so. So Ctrl Z works as well. So why learn hotkeys if you have gizmos? Is because remember that first part where I mentioned earlier, right? If you shrink that technical part, right, down to a minimum, right, then your creativity can flow. Okay? If you're not spending your time looking for little buttons to click, right, and you just kind of do a hotkey like G is for move, right? R is for rotate, S is for scale. Okay? Then things actually move a lot faster. Okay? So the other concept that people have to kind of get used to in Blender is that sometimes there is a follow-up action after the action that you've committed. So for example, if I press G and I move this object, right, there is a follow-up action that Blender kind of allows me to choose, which is, would I like to lock this object to a particular axis? So you can sort of see down here, right, at the bottom bar, there is a row of options for you: x-axis, y-axis, z-axis. So that's kind of like an easy reference for you. But basically, if you press X, you will lock this object to the x-axis, Y to the y-axis and Z to the z-axis. If you press Shift X, you lock it to the certain plane, right? If I press Shift Z, you lock it to another plane. Okay? So that's it for moving the object in object mode, right? Then next up is you want to basically work with changing the object, right? So what we're gonna do is we're gonna press Tab and go in there, and we're gonna start selecting some faces. We're gonna press 3 to select faces. I'm gonna switch off the gizmo so it's easier for you all to see, all right? Okay. So if you select a face, okay, and then you press move, okay, you can move this face away from its original position. Okay, so I'm just gonna move some of this around. Okay, like so. Okay, the next tool that you should get used to is the inset tool. Okay, so the inset tool will allow you to take a certain face and then create a smaller face within it. Okay, so that button is I. Okay, so if you press I, okay, and you move this mouse around, you can sort of see a little window kind of appearing, right? So you can do that. Okay, you can do it for any one of these faces. Okay. Right. So, okay. And then the next tool that you want to play with is extrude, right? So if you press the letter E, okay, you can extrude that particular face, okay, from where it was before. So you can do it as many times as you like so. Okay, you can do it to faces like this, right? Or you can basically inset it like, right? So you push it back down. So these are some basic tools that will be very useful for you to create a wide variety of objects, especially if they are rectilinear in shape. Okay? If you ever wanted to create something that's a little bit more organic, right? Then you need more vertices, right? So one way, okay, to do this is to use Control R. Now I'm just going to use hotkeys right now, but all these buttons that I'm mentioning, right, actually exist on the left-hand side panel over here. So if you want, you can go and look for it, right? Okay. So Control R, and if you highlight an edge, right, what it does is that it adds a loop edge. Okay, so it creates a line around the shape, okay, where you're kind of positioned. Okay, so Control R, okay, and then left click, and then they'll ask you if you want to slide it around. If you don't want to slide it around, you just right click on it, right? So by default, it takes the midpoint of that edge that you're moused over, okay, to create an edge loop. Okay, right click. Right. So this is quite a very fun and easy way to add more edges and vertices, right? Okay. Then of course, if you wanted to, you can go to vertex mode, and then you can kind of shift these things around any way you want to, or you can use edge selection as well. Okay, and move them around. Okay, it's the same thing. Okay, I'm gonna undo this. Right. So other things that you may want to play around with is the bevel tool. So if you select, well, you could select a face, right? You could select a face like this. If you hit Control B, right, and then move your mouse around, okay, you will basically chamfer the edges, right, of that around the shape that you selected. Okay. Now, if you ever pan around a little bit too much and you lose sight of your object, basically you could hit Home button, right, and it will kind of zoom in and frame your mesh for you. Okay. Right, so Control B to chamfer, to bevel. Okay, that will give you some nice corners and edges over here. Right. Okay, so give yourself an activity, right, to practice with this. And just get familiar with it. Like tell yourself, let's make a chair, let's make a table, right, with these basic tools, and then just get used to the workflow, right? If you're new to this process. Okay? And then of course there are a lot of other tools available, right? But don't kind of get ahead of yourself, right? If you're new to this, right? Get used to some basic tools first, and get creative with them. And then after that, build your knowledge out from there. Then you start experimenting with other stuff, right? You can experiment with the knife tool, right? Or spin or smooth and so on and so forth. Okay. Right. So inset, bevel, extrude, right? These three tools will kind of go a long way for you. Right. So the next part of this process, okay, is that we need to work with UVs. Okay, so I'm gonna move things along now, right? So what you want to do is you want to exit your edit mode, okay, right? And in Blender, right? Remember in 3ds Max, I just dropped a texture in, right? In Blender, it's not so convenient. In Blender, you actually have to create a material to be assigned to this object over here. So we're gonna go from layout or modeling, whichever one you are in, it doesn't matter. We're gonna go into shading, right? Remember, I told you that material is like it's like a recipe, right? So this very much looks like the Unreal Engine recipe. So we're gonna create a basic input texture for this. So we're gonna hit Shift A. Now Shift A is a hotkey in Blender that allows you to add stuff from a library of things. Okay, so it works in the modeling viewport as well. If you wanted to add a mesh, you can press Shift A, right, and select a cube or a cylinder and whatnot. Okay, so in the same way in shading, you can hit Shift A and go to Texture and Image Texture. Okay. Now that we have an input, well, it's an empty input, right? There's no texture assigned to this. We're going to create a default one. So we're going to click on create a new texture, and the generated type will be a UV grid. So this will be Blender's auto-generated UV texture. Okay. Then we're going to connect color to base color, right? And then this will basically complete our recipe, right? So the beef ingredient has now been connected, and then they're going to show the end result, right? Okay, so this is the end result. And you can see that there's some things kind of weird about it, right? Like, for example, firstly, the texture is supposed to look like this, right? So it's a perfectly square texture with a cross in the middle, okay? But on our object, okay, it looks a little bit like this. There are these long elongated lines over here, right? And some of these faces here look like squares, some of these don't, right? And then this one particularly looks very compressed. So this is because we haven't fixed the UVs of this mesh just yet. Now, for those of you who are new to UVs, right, the way that I like to explain UVs is UVs are kind of like TV monitors, right? So imagine that this object here is made up of a lot of TV monitors kind of connected together. And each of these TV monitors can display a part of the texture, right, or all of the texture, right? So they can either work together, right, to show one texture, or they can each individually show, some different part of the texture by itself. Okay, so I hope that kind of works for you, right, this analogy. Okay, so what we're going to do here is essentially we're going to now modify those TV monitors. So the reason why you see these long elongated lines over here is because the TV monitor is being told to display nothing more than a single pixel on its entire screen, right? So its entire screen is this entire face over here, and it's being told to display only one pixel. So it shows that one line of pixels repeatedly throughout its monitor. That's why you see this long elongated line, okay? Whereas some of them are being told to show the whole texture, okay, on its surface. Okay, so let's go into UV editing. So to do UV editing, you will go into the UV editing panel over here, right? And then you will see this screen over here. On the right side, we have the viewport. On the left side, we have the UV editing screen. UV editing does not have 3D coordinates. UV editing only has 2D coordinates, right? So that's U and V, right? So it's not X, Y, Z, it's U and V. Okay? And it starts from the bottom left-hand corner and works its way up to the top. UV coordinates actually only have 0 to 1, right? So 0 being the left-hand corner, bottom corner over here, and 1, 1 at the top right-hand corner over here, right? This UV space, right, will map itself onto your texture, irregardless of its shape, right? Whether it's a rectangular shape, right, that looks like this, or rectangular shape that looks like this, it's 0 to 1, right? 0 on one corner and 1, 1 to that other corner. Okay, so it's the same throughout. Okay, no matter the shape of your texture. And what happens outside of this UV space, right? So what happens on the outside of this UV space is that the texture then repeats itself, right? Sort of like a Pac-Man map, right? So you start all over again from 0, right? So if you're out here, right, then really you're somewhere back here, right? You're displaying the same texture, part of the texture somewhere back here, okay? So very important to keep this in mind, okay? So the UV editing tools in Blender are not exactly what I like personally, right? They're pretty robust, but it's a little bit all over the place for me. Too much of that. So y'all may get a little bit confused. So if you do, don't feel bad, right? Even I get confused. What you want to do is first you want to start by selecting a face. So if we select a face here in this viewport, you will suddenly see a change in the UV editing panel on the left. Okay? So what happens on the left is that they will display the selected face for you on the screen, right? As well as the texture that it's using. If you would like to show all of the UVs, okay, from the model, then what you would do is you would select the sync icon over here. So you're going to see the UV sync selection. So if you select that, then you will see all the UVs being displayed on the screen over here. Okay. Now, so if I select all the faces, right, then you'll see, okay, everything getting highlighted over here. So when we talked about the TV screen, right, this is essentially what was happening, right? So I'm going to show you very quickly. I come over here and show textured, right? Okay. So remember the part over here, right, that was elongated, right? If we select these faces over here, you will sort of see on the left-hand side, nothing has really been highlighted other than this line over here. So we've got 4 faces worth of UVs getting kind of compressed into a single line. So that's why it will only show that single pixel all throughout these 4 faces. Okay, understand? Okay. So what we want to do really in UV editing is that we want to, like a piece of paper, right? We want to kind of unfold all these faces so that they all have the same shape as they do here in the 3D model, and they have their own kind of comfortable space here on in the texture space. Okay. So a quick way to do that is simply to press the key U, right, to open up this option here, and to use the Smart UV project. Now, the Smart UV project is an automatic tool that will unwrap all your tools according to its faces. Okay. So this is very useful for these rectilinear kind of blockish shaped models. Okay, so let's try it out, right? So one thing they're going to ask you for is the angle limit, right? So 66 degrees. So anything under 66 degrees will be packed together. Everything over 66 degrees will be kind of separated, right? So that's generally what it kind of means. So let's just leave it as default and let's click OK to see what happens. Okay. So you can see that the 4 faces that I selected just now just got unwrapped. You know, they got removed from the main group, and then it kind of got slapped out onto the side over here, right? And if you look at the shape, right, it went from a flattened line into something that resembles the 3D model's shape very closely over here, right? Right? So that's what it looks like. So let's take everything, right? Let's press A to select all, and let's do the same thing again. We're going to press U and Smart UV Project and click OK. And then you're going to see that everything now gets unwrapped nicely onto the UV space over here. Okay, so you can see if I rotate around, you can see all the texture looks pretty nice, right? It looks very even. The cubes all look the same size across the model. There aren't cubes of like different sizes, and there's no stretching, right? There's no stretching. Everything looks very neat and clean, right? So the only thing that is not too perfect about this is that the boxes, the textures don't line up, right? Exactly. Okay, so you can see these seams over here. This is what we call texture seams, where the texture kind of gets cut off, and then, you know, another part, the different texture kind of runs on the other side. Okay, so UV editing work often revolves around fixing this sort of issues. Okay, but we're not done yet, right? This automatic tool was really handy, right? But you can see that by default, all these UV, what we call islands, are kind of packed really close to each other. That's usually a no-no in UV editing work. What you want to do is you want to leave a little bit of space between each of them. I'll explain why. Okay? So to do this, okay, we will use the UV tool and go to Pack Islands. So once I click on Pack Islands, you're going to see a little kind of dialog box appear at the bottom left-hand corner over here. So if you open that up, okay, you can actually increase the margin value, right? And then this will help to space the individual islands out from each other. Okay? Now this is very useful, right? Because what tends to happen between these islands is this thing called texture bleeding, right? Or pixel bleeding, where if you imagine that one of these checker boxes is a pixel, right, of your texture, and if your UV islands are too close to each other, all right, they will end up sharing that pixel, right, with each other, even though they're supposed to look different. Okay, so having a little bit of space in between each other is quite important. Now, how much space is enough? It really depends on the texture that you're using. If you're using a very high resolution texture like 1024 or 2048, then you can afford to keep a relatively small margin, right? But if you're using a very small texture like 64 by 64, then you want to keep the margins bigger, okay? Right, so that's kind of the rule of thumb there. Okay, so let's recap the process, right? We selected all the faces, we did a smart UV project, and then we set the angle limit and we click OK, right? Then after that, we went to UV and pack islands to give each island a little space between each other, like so, all right? So everything's very neat now, okay? Everything's the same size and we're done, okay? We can now kind of move this. If you're happy with this, you can actually move this to a image editing software, which we will do now, right? We'll go to UV and export UV layout, right? So keep in mind that your UVs need to be selected, right? So remember, press A, select all your UVs, and then you can go to export the UV layout. So you pick a texture size, right? 1024 is pretty much the standard these days. We export the UV layout, right? It will generate a texture. So we're gonna now go into an image editing software. So once again, I like to recommend a free software. GIMP 2 is my recommendation for you all, because it most closely resembles Photoshop in terms of, you know, the robustness of the features, and basically the working style, right? There is another option for you all to consider, which is this website called Photopea. Right, let me just try and call up the window. Okay. Right, so if you go to the Photopea website, it is basically an online Photoshop, right, created by one guy, and it's available for free with ads, right? But it's really good. This actually resembles Photoshop even more closely, right? All the menus and the functions and even the hotkeys are very similar to Photoshop. So if you learn Photopea, you're basically learning how to use Photoshop. But if you prefer to use something offline, right, then I would recommend you all to use GIMP. Okay. Let's see if I have GIMP installed. I do not in this account. All right then. So so my apologies. I will use Photopea, and that's the case. Oh boy. Okay, let's hurry. Okay, so let's drop this in. Okay, and this is basically your UV layout, right? So from this process here, you can basically start to edit the texture and you know, color things in. So in software like this, you work with layers, right? So using this as a base layer, you can create a new layer, right? Fill it up with color or drop in a texture or whatever. Make sure that those layers are below your reference layer, right? Like so, right? Then after that, you can create as many layers as you want and go in there and start painting, right? So draw whatever you want, okay? And then hide your reference layer. Then export this out again as a, what we recommend for you is to use TGA, right? I'll explain more next time, but TGA will be a better format for you. Okay, so export this in TGA. They ask you whether you want to have to use. They don't even ask. Right. Then you can just drop this texture back into your model. Right. So let's just cover that very quickly. Let's see. Okay, so that's that over there. Okay, so you can come back into shading over here, and you can create a new texture. Okay, image texture. Oops. So you want to delete this. Okay, and put in the texture that you've created. Is this it? No. This is the, then you click color. Right. Okay, so now the texture goes onto the mesh, and then we can go into the next step, right? So you have your model, you have your UVs, you have your texture assigned to it. If it looks exactly like what you want it to be, then you can go into the export. So you go to export, FPX once again, okay, and then give it a name. So the FPX settings are here on the right hand side panel. If you are working with bones, then there's some extra stuff for you all to check over here. But I think in general, this is all you have to set. Maybe you want to select selected objects, then just export FPX. Okay, then we end the process. Okay, we end our loop by going into Unreal. Okay, and dropping this in. Okay, so that's about it. Okay, right. So that's the basic workflow for working in Blender. All right. So you have your 3 basic tools. You're working with UVs, right? How to kind of unwrap them, how to assign texture, how to move it out, and then how to bring it into a 3D software like this. Okay, got it. Right. So get familiar with this process first before getting into deeper things. Okay. Now let's very quickly get into animations. Right. All right. So once again in Blender, right, we go back into modeling. Okay, so the thing to know about animations is that when you try to animate a mesh, right, sometimes a mesh may have too many vertices for you to move individually, right? So imagine you're trying to tell the software, please move this mesh, right? And then all they understand are coordinates of vertices, right? That's all the software understands. Okay, so what it understands is that it tries to move all these vertices one by one. So that's why they came up with skeletal animation. So bones will be attached to the mesh. So each bone will control some vertices to some extent, right? So some of them will control them to 100%, some of them will control them to 40%, right? And then you will animate the bones. So the animation data is stored for the bones, and the bones will control the vertices, right, using weights, right, or skinning data. Okay, so let's do a quick demo of this. It's gonna create a new file, right, and let's just create a quick model. Okay, gonna hit Shift D and then Z to duplicate. D and Z. Okay. Okay. Right. So what I have here is a collection of 4 different meshes, right? So it's very important for you to take note that usually for your game engines, your meshes should really be one mesh, especially if you want to animate it, right? So one mesh, right, and then one set of bones, okay, is the general rule of thumb here. So what we'll do is that we will select all these meshes, right, and you want to select the mesh that you want to use the pivot for, okay, to be the last. So we're going to select all of these, and then this one we're going to hit Control J, right? Then they're basically going to merge all the mesh into one, right? So we're in object mode, we use Control J to merge all these different shapes into one, okay? Then you can sort of turn on like a transparent mode to see through the object. So the next part of this process, after you have your mesh, right, is to create a set of bones. In Blender, it is called an armature, right? If you press the keys Shift A, okay, you can find a whole bunch of stuff to add to the scene. We will use Armature, okay, and you will see then they have added this single bone over here. Now, what are bones essentially, right? They may look like sticks, right? But essentially, they're actually a point. And that point is that point of rotation. Okay, so that's very important to take note. Don't be confused that, you know, bones are sticks and then, you know, where do you rotate? In the middle of the stick or the end of this stick or this end of the stick? It is really the thicker end, right? As shown over here. Okay, and it's a single point. So this stick will basically rotate around that point. Okay, so as you add more and more bones, right, that rotation point is at the end of this particular stick. Okay. So how do you work with this, right? So what we want to do is, if you want to animate a character like this, is that you have to decide where those points of rotation are going to be. Okay, so obviously for the arm, it's going to be around here. For the head, it's going to be around here, right? Okay, so you got to go into edit mode, right? So we hit tab again, okay? And in this mode, you can select the end of this tip and you can sort of move this up over here, okay? So the reason why I'm moving this up is because I want to set the next point of rotation to be here, okay? Then next, I'm going to press E. By pressing E, you'll basically create a new bone, okay, to be attached at the end of this. So if I press E, okay, and I press Z to lock it to the Z axis, okay, I can then shift this up. Now, where do I end this, right? Do I end it at the top of the head or what, right? It really doesn't really matter if this is the end of it, because really all what we wanted was the starting point, right? So if you want to leave this end point here in the middle or at the end of the top of the head, it's really up to you. It doesn't make any difference, okay? So we just leave it at the top of the head. Then after that, you go back down to this end point over here, because we're going to extrude out 2 points from here. So E, once again, and then we're going to leave this along the y-axis, okay, over here. We're going to then press E again to bring this down, the z-axis. Okay, again, where this ends doesn't matter. Okay, E, Y, E, Z. Okay, so that's basically it. This is your hierarchy of bones, okay, where bone is the top one, right? We're gonna rename this F2 root bone, okay, rooto bone, and then bone 1 is gonna be our head bone. Then bone 2 is gonna be our clavicle left, and bone 3 is our arm left. Okay, and you can do the same for the other two. We'll just skip that for now. Right. Okay. Then we're gonna exit out, go into the object mode, and this time we're gonna select our cube, right? Our combined cube. Okay, and select our armature. Right. So we're gonna select both of these, and let's see if I remember this correctly. Right click, parent, and armature deform with automatic weights. Okay, so basically this will now bind the mesh to the bones, right, and then give it some default weights. So the next part of this process is painting of weights. Okay, as you can see, when we move the bones, it doesn't really deform very nicely, right? You see a little bit of twisting over there. Okay, so we want to change the weightage. What's really happening here is that the bone that I just rotated controls all of these vertices, but this vertex over here that's hardly moving, okay, is controlled by this bone, but more so by another bone elsewhere, right? So to resolve this, we will go into a different mode. Let's go into object mode first and select the mesh. Then we will go into weight painting mode, right? And then this will allow us to see how the bones are weighted. Now, to see this better, right, you now have to go to the right hand side panel over here and go under the object geometry properties over here, right, and look under the vertex groups. If you select the bones, right, you will see that the way the vertices are weighted to that particular bone. You will see that the head bone controls most of the vertices up here, but because it's not red, right, some parts are green and yellow. It means that the vertices, some parts of the head is being controlled by another bone elsewhere. So we don't want that, right? We want the whole head to be controlled by the head bone. So to do that, go into this draw mode, make sure that your weight is 1, make sure that your radius, right, is set to appropriate size, okay, and your strength is 1, then go ahead and just paint over the vertices, right? So once you move over the vertices over here, right, you start to see this cube turn completely red, right? It may take a few strokes, right? But once you see that it's turned completely red, then you know that the whole head is going to be controlled by only the head bone, right? Okay, so we're going to do the same for the left arm over here, right? So we want this whole block over here to be controlled by the left arm. You can see I accidentally painted over on the other side. So we're going to lower the radius a little bit. Okay. And weight this completely. Of course, you can do the reverse and set it to 0, right? And then paint this other side here. But in general, you want to add and not subtract, right? Because whenever you subtract, where is that weight going to go, right? Just in case, you know, it doesn't go somewhere you didn't intend for it to go, you just stick to adding, right? We're gonna do the right arm first. Okay, make sure that this is all red. Then after that, we're gonna go to the body, right? So the body, maybe I'll just weight it to the root bone, right? Oops, Ctrl Z. Okay. So things may be a little bit different with Blender, so I'm just going to be sure, right, and just check my other arms. Okay, so it still has that little bit of weight, so make sure that this is set to 0, and oops, and get rid of it. Okay, so I think we're good, right? Once we're at this stage, basically, the vertices are binded properly to the bones, and we can do our animation properly, right? So we're going to go back up to object mode. We're going to go back to our armature and go to pose mode, and you can see now when I rotate, right, it should work a lot better. It's still getting deformed because I think I should have painted 0 on some of those vertices. Okay, but this one works just fine. Okay. So maybe we go back to cube and fix this a little bit more. Okay, yeah, so you want to set these to 0, maybe increase the radius by a lot. Go blanket it. Okay. Right. Okay. So this looks clean now. Okay, yeah. Go back to and pose mode, and now this is much better. Okay, right. So this is what I wanted. Okay. So now with this done, right, the skinning and rigging phase is over. Now you're ready to animate. Okay. And with animation process, what we do is that we need to go to the animation timeline over here, right? You can turn on the see-through mode here, okay, to look at the bones. So remember, we're not going to touch the mesh anymore, right? For animation, we only touch the bones. We only set the keyframes for the bones. So the process of animation or keyframing animation is really all about setting key poses at certain times along a timeline, right? And then what will happen is that the system will interpolate between these two key poses. So if you have one pose where your left hand is up, and then somewhere 30 frames down, your left hand is down, right? Then everything, the position of the hand throughout this in-between period, right, will be interpolated smoothly from point to point, okay? So, so let's begin, right? Firstly, what you want to do when you begin animation is that you want to make sure that your frames per second is set to the correct value. To do this, you go under the output properties over here, and then make sure that your frame rate here is perhaps set to 30 frames per second. Okay, and you can set however long you want to work with on the timeline, right? So let's just say 100 frames. Okay. Then after that, you will turn on the auto key feature, right, which is down over here, the record button. If you turn on auto keying, then the automatic interpolation of your keyframes will happen, right, as I just mentioned. Okay, so let's begin. Okay, usually in your first frame, you would want to set a keyframe for all your bones. Okay, let me just show you all what will happen. So what we'll do is that we'll press the key I, right, to call up the insert keyframe menu, and then you would set either the whole character, or you can set location rotation scale, right? If you select a bone and then you only set location rotation scale, right, it will only set the keyframe for that particular bone, right, not for the other bones associated with it. So this could cause some problems later on. Okay, so maybe you want to do whole character. So they will select everything in the hierarchy, okay, and then set the keyframe for it. So you can see under pose, you select your different bones, right? You can see that they all have a keyframe now, as indicated by a yellow dot. Now, 30 frames per second means that every 30 frames, a second has passed. Okay, so if you imagine that 1 second later, what kind of pose would your character be in, right? Then you would set that pose accordingly. So now, if I were to rotate, say, my left arm, right? Maybe I want to lock it to a certain axis like this, right? And I set it, right? You will see that on the timeline, a keyframe has been automatically set for me, right? That is due to the auto key feature over here. And if I scroll, right, you will see that it will move smoothly from point to point. If this wasn't on, basically it will stay in this position and it will pop to the next position at frame 30. Okay, right. So you can do the same with these. Okay, so set a keyframe, right? Then you just basically move on to the next keyframe, right? So maybe 30 frames later, you would like to adjust this and move it to the other direction, like so. Okay, and it will set a keyframe automatically. You can see this is happening, right? So I kind of made a little mess of it, right? The way I rotated it, but you'll get the idea. Okay. So the other thing that you should kind of play around with is you can then select these keyframes and you can actually move them down the timeline or up the timeline accordingly, right? So if you want to speed things up, you can actually move these keyframes up, say 10 frames, right? And so on and so forth. Okay. Right. So you can also copy the keyframes, of course. Okay. You can perhaps select all of these, okay, and then you can just select these and then do a Shift D and move this down to the end over there. Okay, and this will basically complete the loop. Right. So this is basically the whole process of keyframe animation in a nutshell. Right. A good way to kind of play with this is perhaps to create a little robot like this, or to create a little treasure chest. Right. Perhaps you have an opening and closing action. Okay, and then keyframe it to see what you can do with this process. Then after that, when you're done, okay, you can just simply export this model, right? So let's get out into object mode. Okay, and let's see, we don't need the camera, we don't need the light, we don't need this. Take this, and we'll just export. Again, FBX, right? Once again, FBX will support bones and animation data. Okay, you can see it down here, right? Big animation, okay, you can leave this as it is. Then selected objects, right? Then just export FBX. Okay. In fact, let me just make sure I saved in the right place. Okay. Test robot. Okay. And then let's bring it into Unreal Engine. So in Unreal Engine, they're gonna ask you for whether you want to import animations. You gotta remember to check this. Okay? And since this is the first time that you're bringing this model in, it's going to use a new skeleton. So under skeleton, you just leave it as none. Okay. But if you brought this in before, or you bring in another model that shares the same skeleton or hierarchy of bones, right? Then you can assign this accordingly, right? And just hit import. Okay. And let's review. Okay, so you can see in Unreal, they generated a whole bunch of stuff, a skeletal mesh, right? Skeletal mesh over here with its skeleton of bones. They brought in the animation file. Okay, so everything's in and all kind of linked up. Okay, so we have this right now. Okay, we can see it playing the animation. A little bit far away. There. Okay, so that's our killer robot doing his looping animation. Okay. Right. So that's it, right? That's basically the animation workflow in a nutshell. There are definitely more advanced things that you can do, you know, like playing with curves and whatnot, and working with inverse kinematics and forward kinematics, but I don't have time. I've already been kicked out of this meeting twice already. My apologies, and made you guys have to kind of come back in. So let's end the meeting here, shall we? Right? This is basically all I wanted to cover for today. I did want to cover a little bit more, like for example, using Unreal Engine's own modeling tool. You can go to modeling tab to create your own meshes, right? And even edit it, right? The way you would edit, you know, a polygonal mesh as we did just now in Blender, right? You can do everything like inset, okay, like so. You can do extrude. Okay, like so, all inside of Unreal. So the difference between Unreal Engine and working in Blender is that Unreal Engine is not using an orbital camera. It's using kind of like a game camera. So you're kind of using the right mouse button and WASD to move around. So for some of you, this might actually be quite intuitive, right? Once you're done with this, you can click accept. Okay, and there are also UV unwrap tools over here, as well as you know, the fact that you can actually export this mesh. Okay, so if you hit Control B, I think, when you select this mesh, they will bring you to where they save that file. Okay, right, so that's your mesh saved out as a static mesh. You can actually right click and asset actions and export this as a FBX out of Unreal Engine to be used in your game engine. So, you know, pretty handy as well, right? Okay, so, well, I guess I did cover it in the end, sort of. Right, so that's pretty much all I have for you all today. Okay, I would like to have had more time to show you all some examples, you know, of previous works and talk a little bit more about all this kind of stuff in detail. But I guess, you know, there's only so much that we can talk about in one day, right? So I'll post the links to, you know, to maybe a PDF file, and links to some of these software and some of these working files for you all to download. I have some useful assets for you all to work with. In general, you all can also use certain assets for GAM, like these free assets from Kenny Art Assets, right? A good one that I highly recommend is the prototype pack. You can grab this and do your level editing. In fact, in Unreal, there's a pretty cool feature where you can actually build by cube grid, right? So it's a little bit like MagicaVoxel, where you can just kind of click and press Pull or E, right? And then it just kind of pulls out a cube, right? Voxel style. So you could actually do your level editing pretty quickly using this tool, right? And then once again, you can save this out as an FBX file if you want to, okay? And there are UV editing tools for you to use as well. Okay, so lots of useful tools, lots of options for you all to play around with. You all have, you know, half a semester to just tinker around. Okay. Right. So this is useful. There are some other free assets here, like ambient CG. These are also free and okay for you all to use that you can download. Some of these textures are actually generated with Substance Painter. So if you're interested, we can talk about that at some point as well. If you want to delve deeper into Blender, you can check out Arima's 3D, right? I respect this channel a lot. This guy does a lot of great videos, primarily with 3ds Max. So if you're gonna take your CG125 later on, you can check out this guy's videos. They're very detailed and very high level. Or you can check out his Blender videos. He did a whole series for Blender as well. Okay. But otherwise, yeah. Otherwise, then there's my channel, right, which I'll be building up from the ashes of my old videos. So when that's up and ready, I'll share that link with all of you. Okay.